ready? Okay, then, get ready. Here we go. You've already learned why a function is not differentiable. 3 reasons. They are not continuous, sharp turn, vertical tangents. Vertical tangent is undefined, 0 in the denominator, rise with no run. Now, you should be able to use those in an AP kind of setting. At what point, one of these questions is bogus, but I can't remember which one. At what point is the function continuous but not differentiable? Give me one. X equal -1. That's true. Any others? X equals 0 because that's a vertical tangent. Yeah, -1 is a sharp turn. And let's go with x equals 0 because there's a vertical tangent. Okay. Okay. Okay, whatever. At what x values is the function not differentiable? Give me all values it's not. X equals, obviously x equal -1 and 0 are there because we already did those. Any others? 2. Yes, there's a discontinuity there, and -2. Okay, all those are no derivative points. At what point is the function differentiable but not continuous? Not possible. Okay? Think of it like this. Think of a Venn diagram. Differentiable is a subset of continuity. You cannot be differentiable but not continuous, yeah? So just for matter of practice, give me something to put here on the Venn diagram. Give me a graph I could draw here. So sine is both not differentiable and not continuous because it's outside. So here, do you agree, here in the Venn diagram is not in the continuous set and not in the differentiable set. So give me a graph to draw there. Here, not benefits. Maybe I'm not making myself clear. Okay, do you understand Venn diagram?
Yes.
Okay. Do you agree that this is not in the continuous set, so it should not be continuous? So can you give me a graph that's not continuous? Just tell me to draw something. Something with a hole. Perfect. See, that was real easy. Okay? There you go. Something with a hole. Not continuous. Something with a jump discontinuity. Something with a vertical tangent. All those would be that set. Yes? Okay, cool. Do you agree that that is both not continuous and not differentiable? Cool. Give me a graph to draw here. Tell me some. You don't have to name the function. Just tell me what it looks like. Sharp turn. Perfect. Okay, the seagull function. Cool. What about here? Parabola. Sure. Anything that's smooth, locally linear, we're all good to go. Okay? All right. Would you try this major gotcha? This was on an AP test about 10 years ago, and it was had a really low average because people didn't think about it the right way. Give it a go, think it over, talk it over. We'll go over it in a minute. No, maybe it's easy. I love that you're you're up. At least you ruled out the conclusion. So good job. Are we ready? Okay. Tay, you said it's A or C. Why do you say that?
Well, I looked at when f prime is 0.
Okay, so you said flat, flat, flat.
Yeah.
And that felt like these. Doesn't that also mean this is possible? Why'd you dump B? It's flat, flat, flat. Okay, so I agree that D's gone, or by derivative 0, justification, D's gone. No good. Okay, what else? It's always, think, this is a line, yeah? If f prime is a line, then what's f? Squared, parabola, right? So it should be parabola and parabola, except this parabola is a negative line, yeah? So it should be, because this is negative x, then f should be negative x squared, yeah? So this should be, now that still seems like parabola, down parabola. This is parabola, but this is not down parabola. That's gone. This is parabola and down parabola. That's still in. A and C seem logical. How do you make the case? And this also looks like f prime is x squared. So f is x cubed, yeah? And that also feels right and right. So which one is it? A or C? A. Why do you say A, Brian?
Is it because C, the graph of f prime wouldn't exist at 2, 4.
Beautiful. Okay, this cannot be f because it's discontinuous at 2 and 4, right? Which means f prime does not exist at 2 and 4, and yet obviously f prime does exist there. Those are points there. So it is A. Hold on. Okay. Alrighty. Let's talk another idea of continuous and differentiability. These tend to go pretty well. It's just gathering two pieces of evidence. So you've got the condition now that you have a piecewise function, and now you want two things to happen. You want it to be continuous, so you have to make sure the one-sided limits of the function meet, but you also want it to be differentiable. Now, if it's differentiable, then it has to be smooth, a smooth meeting at the intersection. The slopes must be the same. Otherwise, you'll get a sharp turn kind of thing. So we want to join two pieces, so it's continuous, but we also want the derivatives to be the same from each side, so it's smooth and therefore differentiable. You down? All right. Now, if you think about this, we'll get to this in a second here, but think visually. I'm trying to make it so that this parabola that looks like that, and a line with unknown slope and y-intercept, so it could be who knows what, so that at 2, not only do they, here's 2, at 2, not only do they meet, but they also smoothly transition from slope from one end to the other. So I need to make both of those match so that right there, they meet and smooth. You down? Okay, so cool. Let's start with continuity. The idea is that the limit from the left of 2, now when you use a piecewise function, you say, hey, here's the piece I'm talking about. So from the left, the piece I'm talking about is 3x squared needs to meet the limit as x goes to 2 from above, which is the other piece of the piecewise, x plus b. You down? Now, if I evaluate the limits, what does 3x squared approach as x goes to 2? 12. And what does ax plus b approach as x goes to 2? 2a plus b. Now, at that point, I don't have anything more to do, so I need to gather more information. Now, for the differentiability part of this, I need their derivatives to match as you approach 2. So, the slope from the left. What's the slope from the left? Well, here's the function on the left. What's the derivative on the left? 6x. It needs to match the slope from the right. What's the slope or the derivative on the right hand? A. Now at 2, what does 6x approach? Or what slope does the parabola leave off with when they meet? Well, that means the line has to have a slope of 12. Now, we also need to make the line in the right place. So if A is 12, then B is something like 12 minus 2 times 12, or negative 12. By making the line a line with slope of 12 and y-intercept of negative 12, they will meet and smoothly transition slopes. This here is called locally linear, which is to say, if you zoomed in on this, when they meet, it would look like a one. Yeah? Although they are two totally different groups. Nope. One on for you. Try one on your own to make sure that you get the gist. Everybody else is here. Doo-ba-doo. Did you get an A of -1? And did you get a B of something else? -3? +1? Okay, cool. Just so we're clear on my expectations, students tend to say, I don't need to do all that limiting stuff. This is really, they want to jump to the, not okay. In fact, I don't even consider that done in the homework. I would consider that skipped if you failed to show the limit of the functions and the limit of the derivatives. That is, to me, good calculus. Just this, that's garbage calculus. All right, understood? I get it, Mr. Rickman. You are warning me, and I get it. Good deal. Cool. All right, I'll fill the whole problem, but with continuity. So, this is an AP problem. Give it a go. See what you think here, and we'll talk about it, and then we'll try something totally new each other. we ready? Okay, what do you say? Is one true or false? True. How do you do the limit as x goes to 2? If x goes to 2, do I go to at 2 or not at 2, around 2? Around 2. So I should be looking at around 2, and that approaches 4. All right, so it appears like, yes, there's a limit. The left and right are the same. We're all good. So 1 is definitely true. 2 goes to, did they fill the hole? Would you agree that 0 over 0 is a hole in the graph? So this wants to be x plus 2, but has a hole at 2. Question is, did they fill the hole? They put the point at 1, not 4. We know the limit was 1, but they put a dot at 4. Therefore, they did not fill the hole. So is it continuous? No. Now, do we even need to get into the slopes or anything else? No. If it's not continuous, then it's definitely not differentiable. That's out. So it is just 1. Yay? Okie dokie. This then is the hardest part, and it tends to be a little iffy for students. But with good practice, I think I gave you a prompt for first remember the alternate definition. Did I? Did I put something in there like write the alternate definition of the derivative?
Yeah.
Okay, cool. Do you remember the alternate definition of the derivative? The derivative at some point A is the limit as x approaches A of minus over. Okay, now just to really quick review the whole idea of the derivative, yeah? Say you, let's graph this guy. What does this graph look like? We'll do this in a second. It is a absolute value graph. Well, there's lots of absolute value graphs. Be more specific, please. Shifted right too, and it is what kind of shape? V. Okay, is every absolute value graph a V?
No.
Certainly not. It goes to what you're reflecting up, yeah? This is a line getting reflected up. That's why it's a V. It's not like it's always a V. The concept is reflection up. Depends on the graph you're working on, right? Okay, cool. That said, let's talk graphically, then we'll prove here. Say the idea of a derivative is to take a point around the point you want and draw the slope between them. That's the secant slope. That's what this part is. And then it says, as you get this point closer to 2 and draw the slope, and closer, draw the slope, and closer, draw the slope, what do the slopes approach? Yeah, that's the idea of the derivative in all its forms. You with me? The definition of the derivative. We have all these shortcuts, but that's at the very heart, yeah? Instantaneous rate of change at some point. Does A, though, have to be on this side? What do these slopes approach? When A is over here, what's the slope? 1. When A is here, what's the slope? What's the slope? Okay, what's this approaching? 1. Do you agree that the slopes from the right approach 1? Yay? But who's to say A has to be over there? Could be over here. Draw the slope, get it closer, draw the slope, get it closer, draw the slope, get it closer, draw the slope. These slopes, what are they all? -1 every time, -1. So what do these slopes approach? Now, doggone it, a derivative is a limit. And if the limit on the left and the limit on the right are totally different, then that limit doesn't exist. Well, if the derivative is the limit and the limit doesn't exist, then the derivative doesn't exist. That's the proof then that you're going to be doing here. It's going to be something like this. We know the derivative doesn't exist at x equal 2 because there's a corner there. Prove the derivative doesn't exist using the definition of the derivative. Now please, I beg you, every time I put this on the test, I word it almost just like this. We know that the derivative doesn't exist because there's a corner there. Prove the derivative doesn't exist using the... You would be surprised how many people say, the derivative doesn't exist because there's a corner there. Well, good job reading. I already told you that. nor did you use the definition of the derivative. I am saying you prove it. Now, this is what I would love for you to start with. Start with the definition. The limit as x approaches 2 of f of x minus f of 2 over x minus 2. Break it into different pieces for each side of 2. If I were to say, what are all the, what is the function, oops, sorry. What is the function for the left of 2? What is the equation of this in a piecewise-y kind of form? Do I need to do piecewise or can I don't even need to do piecewise. I'll just do absolute values. Okay? Shall I? Yeah, I think you'll find it easier to do. All right. So I'm trying to figure out which will be easier for you. What's the equation for this piece? Negative x plus 2. And what is f at 2? 0. Okay? You down? Okay. As x goes to 2 from, so this is the limit as x goes to 2 from below of negative x plus 2 over x minus 2. What is that limit approach? Obviously it's 0 over 0, but with a little factoring and canceling, it can be negative 1. Now that is 100% what we expect graphically. That's the slope of it, yeah? You with me? What about what the slopes approach when we are on the right side? Now, what is the function when we're above 2? X minus 2, yeah? Minus 0, x minus 2. Well, what do those slopes look like? X minus 2 over x minus 2? 1. That also visually confirms. Now, if the derivative at 2 by definition is this. But also, by rules of limits, if the limits don't agree, negative 1 doesn't equal 1, then what does that imply about the limit? It doesn't exist. Therefore, the derivative does not exist. If the limit doesn't exist, then the derivative doesn't exist. And if the limits, the one-sided limits or the slopes from each side are different, you're going to get a sharp turn. That's why the derivative doesn't exist. Try this one on your own or with your math amigos, and we'll go over it. This does take practice. I'll put a few extra practices on to be good. You're doing two things, showing it's continuous, then showing it's not differential. did it that way, get out your big eraser, 'cause that's garbage. And that is very much the way students want to do it. They want to bleed in the previous from the front to this kind of code. Give you a minute, or are you good? Okay, did the continuity, let's just verify. What are the three parts of continuity? Does G at 4 exist? And what does that mean? What do I look for? G at 4 exists, just check. I don't care about whether it's true or not. I'm just going to say, yep.
X is greater than or equal to.
Yeah. At some point they tell you when X is 4, this is what you do. It's defined. Alright? Or you could say it's defined. What about G of 4? What does it equal? 18. Okay, cool. What about the limit as X goes to 4 from the left? Actually, I should see what branch I'm using. You say it's 18. We? 18. What about the limit as X goes to 4 from the right? 18. And because all those are the same, we say that G is continuous because these are all equal. Whatever. You get the idea. Left hand, right hand. So much writing. Wait. Okay, it's continuous, we're good. Cool? Now, let's talk continuity. Again, or differentiability. Different problems, I require a little work differently here. On these, that's the find the A, the B, I'm okay with show the functions are equal, show the derivatives are equal, find the A and B. That's a multiple choice problem. Rarely you're going to look at your work. It's just doing what you got to do to get the A and the B. Are you with me? This is not that. This is a proof. It needs to be thorough. It is not enough to say, hey, these derivative shortcuts work out to be the same. It's definition of the derivative. Definition. So, the limit as x goes to 4 of g of x minus g of 4 over x minus 4. That's the derivative. If you get into the pieces, 4 from the left, what g do you use? X squared plus 2. What is g of 4 again? 18. I get something like x squared minus 16 over x minus 4. Now all definitions of the derivative are going to be 0 over 0. That is the idea of infinitely small over infinitely small. That every definition of derivative that ever existed is 0 over 0. You don't need L'Hopital here. This factors and cancels. When you factor x minus 4 and drop it, you get x plus 4, and the slopes approach 8. Cool. The limit as x goes to 4 from above. Now g of x will be replaced by 4x plus 2 minus g of 4 is still 18 over x minus 4. That works out to be 4x minus 16. That's 0 over 0. How do you do the algebra there? Factor out of 4 and divide. When you factor out of 4 and divide, what's the slope? 4. Now, with that proof, it's obvious that the one-sided slope calculations are not the same, and therefore g prime at 4 does not exist. That's what it should look like. Is that clear? Okay, the definition of the derivative work here is very valuable, especially in terms of preparing for the AP test. They hit the definition of the derivative on all these different kind of angles, and it's good to have a good solid foundation. All right, excuse me. You only have one homework, yes? Let's see, should we look at the test? Test. I guess we'll look at the test and go over questions on this tomorrow. I don't really have slides on this. I'm just going to let you look at your test and all. All right. There's no 700 graded.
Stop, I'm not gonna get all your other questions are gonna be in text now. Now the whole school is gonna get the stomach. This is all they have. This is it. I'm not gonna get you stomach flu.
I knew it. I knew it.
So this one's easy because this one actually isn't the whole, or it isn't a disc, it's a straight line. But here's the thing, whenever you, whatever axis you rotate it on, that's what you use. Yeah, so you're gonna use whatever axis
Sorry. Okay, just change the order of this a lot. I did. Okay. Let's see, I have your first page then. I didn't take it to the right folder. Okay, so just so we're clear, a lot of this was meant to be a reflection of homework. I pulled some of these directly from the homework. I'm starting to get, in making this test, I'm starting to get frustrated with how many people were just turning in homework that was wrong all over the place, and that's not okay. Just because I don't grade for correctness doesn't mean you shouldn't correct it. That's how you learn. So, big time. Let's see. On the first page, the integral of the trig odd power, that went really well. The tangent definition of derivative, that went really well. The force and work, I was super happy with. Number, depending on the version, either number 4 on the blue or number 3 on the green. How do you find area in a single integral if there are 1, 2, 3 regions? How do you do it with a single integral? Absolute value. You flip everything up by virtue of absolute value. That was straight out of the home problem set. Straight out of it. The minute you did it wrong, did nothing about it, you had it wrong and you didn't care. Then you would evaluate that and you're all good. The volume went pretty well. The continuous one, that went pretty well. Let's talk the back of the first page. The function f and g kind of deal. Some of you really overthought A. It says the tangent line is y equals 4 plus 2/3 x minus 4. That means the slope must be 2/3 when x is 4, yeah? For both g and h. Actually, tangent and h, both at x equal, oh, there's a typo there. Did you notice that? Oh, wow. Maybe that was why you had an issue. Now I get it. Now I know why you're doing that crazy crap. Because I typed it wrong. Okay? So, this is great. This was supposed to be a 2, so that you could tell when x is 2 in question A, when x is 2, the slope is what? 2/3. Now, I don't know if you realize this, and you, that's why you had trouble with it. You just mindlessly plugged and chugged. But do you agree that without this being 2, then you have absolutely no idea how to find this? Okay, so I screwed A up, and I need to give you points back for that. My bad. I'll tack on some. How much was 1 point worth? I'll probably be bumping your grade up by about 2-3%. Sorry. Dang it. I just realized I screwed that question up. I typed it wrong. It should have been x minus 2. Dang it. Shoot. A prime, if A is 3x cubed h, A prime, hi. A prime, what product, or what will you need with the product rule, yes? Okay, so the first was showing the product rule. I can't tell you, I would bet about 8 people did a bad job of factoring the 3 out. It was disastrous. I had a lot of people say, factor the 3 out, and then they said their derivative was, what did they say? They said crazy stuff like x cubed h prime plus 9x squared h. Is that okay? It is not. They factored that 3 out. The derivative there is now 3x squared, not 9x squared. I think you did much better if you didn't factor the 3 out, if you just put that together and that together, all right? And then the second question was supposed to be A prime at 2, but I did A at 2. A at 2 should be 96. Do the question that's asked. C was the meat of the concept. Oops. Oh, wait. All right. C. If so, H is x squared minus 4 over 1 minus f cubed. Yeah. If they say that the limit as x goes to 2 of h is a L'Hopital case, then what does that imply? Either 0 over 0 or infinity over infinity, right? Which is the case? Must be 0 over 0 because that's what's going to happen to that, yeah? Now that implies right away that when x goes to 2, 1 minus f cubed must go to 0, and therefore f must be 1. That's the first part. F at 2 rather has to be 1. If this is a L'Hopital case, it must be some kind of 0 in the denominator case. F must be 1. Next, by L'Hopital, the limit as x goes to 2, wouldn't that be 2x over, take the derivative of the bottom now, please, go. Negative 3f squared times the derivative of the inside, people. Times f prime. How else are you going to find f prime if you don't do the chain rule? If without that there's still no f prime. How are you going to do this problem? You've got to use the chain rule. This is 4. Yeah, they tell you the limit is 4. It's continuous, so it's got to be equal to h into a 4. Well, the top is 4. You know this part is 1. Solve that for f prime. It should be something like negative 1/3. Yay? You got it? And then the last part is a sandwich theorem kind of question. If you did any kind of sandwich theorem work, then it was 1 point. And that's that. Okay, we'll go over the next page tomorrow. I need these back, please. Thank you. Juniors, you gotta get your stuff signed. taking everything. Oh. I'm supposed to do this thing around. Okay, thank you. Okay, thank you. Hi. Yay! All right. Okay. Okay, thank you. Bye. Okay. Thank you. Let me change this up. All right. These. These need to be right here. Yeah, you look great. She's tired. Thank you. Have a nice day. Thank you. Yes. Okay.